Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aris bin Sharin. My matrix number is AA221094. So I will introduce about introduction. Firstly is flip-flop. In electronics, flip-flops and latches are the circuits that have two stable states that can store state information, a bistable multiplicator. So the circuit can be made to change state by signals applied to one or more control inputs, and the output will instead often along with its logical complement. It is the basic storage element in the circuitry logic. Flip-flops and latches are fundamental building blocks of the digital electronic system used in computers, communications, and many other types of systems. So next is finite state machine. State machine, also called as a circuitry circuit that can be viewed as synchronous counter with irregular sequence. There are two types of finite state machine, which is Moore machine and Mealy machine. For Moore machines, it depends on the present internal state only, and Mealy machine depends on the present internal state and also input at the particular of time. So that is the part of finite state machine.
Hi, my name is Muhammad Iqbal and my matrix number AA221453. Register. Register is digital circuit with two basic functions, which is data storage and data movement. Data storage is specifically for memory device, even though in the short term, while data movement is for shift capability in transferring data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Idham bin Muhammad Khalif Faisal. Number matrix AA220969. I will present about how to build the circuit and simulation on Tinkercad. First thing first, when we get the task about building Moore machine using 3 JK flip-flops, first thing first, we must draw our own state diagram. What is state diagram? State diagram is first step before building a table. From state diagram, we can make the net state table and excitation table and also K-map. So this is our own state diagram. So next step, we must do the state table. What is state table? State table is when we comparing present state and the net state. So for example, here 0 0 0 we get from input C, B, A. Then the net state is 1 1 1. All of this we get from the state diagram that I mentioned earlier. Now we must do the excitation table. What is an excitation table? Excitation table is where we find the FFC, FFB and FFA. So here, for example, our present state is 0 0 0. Then next state is 1 1 1. So for FFC, we get 1 1 1 because the input is all 0. Next example is 0 0 1. Then next state, our next state is 1 1 1. So for FFC and FFB is same, 1 1. But for FFA, it turns to 0 because what? Because our output in present, our input in present A is 1. So that's why we get FFA. For K input is 0. So this is our K-map. So for FFA, we get our Boolean expression. For J input is QC bar and K input is QC. For FFB, our Boolean expression, we get JB equals to 1. Then for K input is QA plus QC. For FFC, we get for J input is JC equals to QB bar. Then for K input is KC equals to QA bar plus QB bar.
So we continue to the simulation of Tinkercad for this GK flip-flop. So we start the simulation. Start from 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, and 0, 0, 1. So that is the output of the GK flip-flop. So in conclusion, this output follow our first sequence that Idaham state in the previous slide. So that's all from me.
Let's go to finite state machine in Logisim. The component we need is input, output, JK flip-flop, inverter, and clock and GT. We need to design it on like I show you in the slide. After that, we need to take the result. The result that we take note is like the next slide. Let's go here, the table result. Based on the table, we need to collect the result based on power up, clear, asynchronous, parallel load, asynchronous, shift right, while clear, asynchronous, parallel load, asynchronous, and shift right. We need to put the input is parallel load. The input is parallel load. You can put it on high or low. So after we take the result, the FFA, FFB, FFC, FFD, the output, you can check it when you free. So that's it, our presentation.